Okay, so I was really happy with the questions, and I hope you have more questions. And I actually hope that I didn't answer all your questions, because the more questions you have, the more doubts, the more you are thinking about it. Before we go back, we go out to our places today, I will randomly point out someone to see if that someone has an example of discrete choice experiment in a context that they would like to be thinking about, okay? Just to start engaging you and also to start giving you a little bit of a quick reaction. But of course, hopefully you have enough time today and tomorrow in the morning to do a literature review, a quick literature review, and then a quick semi-structured interview with your parents, with your friends, right? There is always someone in the family who is interested or is related to the topic. And then tomorrow you come out with a subset of attributes that you think are relevant in the context that you are thinking, okay? Just that quick, something dirty and fast, nothing that I will be judging for precision, but more for engagement. So I am going to start the second part with something that is more what is related to the econometrics itself. And the good news is that if you do well your work, there are two words that should not come out in your analysis. You should not be worried about, that econometricians, we are all the time worried about. One of them is multicollinearity, and the other one is endogeneity. Those two things should not come out and will not come out if you do your job well. So that is kind of the trade-off. You do a lot of work, pre-work to the data set and to the gathering, and if you do it well, actually, you will not have to do post-analysis work. Not that you don't have to analyze it and pay attention, but a lot of the analysis when it comes out to doing a good instrumental variable approach is the instrumental variable, right? I mean, this is a 2-year project where you spend 1.5 years estimating the instrumental variable. That's all what it's about. So in this case, no. In this case, it is a 1-year project where once you gather your data, you run your conditional logic, your mixed logic versions, and your latent class logic. Not that it's that easy, but it is what it is. I am, and no reviewer is going to be criticizing your work if you didn't control for endogeneity. Why? Let's see if you guys, I know that several of you are already consummated econometricians, so you probably should have some intuition of why. Imagine that I have a sample of 1,000 office workers that I presented this choice car is called, and I presented 9 of them or 7 of them in this way with different alternatives each time. And then they told me which one they prefer, okay? That is the general description of a discrete choice experiment. Why is that when I analyze the answers, the discrete answers that they provide to this exercise, why do you think that I should not be thinking on endogeneity? Who has an intuition? You are sleepy because you just had.
Econometrics class. We should be able to.
It's okay. If I can repeat it just because I know that people get scared, but I ask people, a sample of 1,000 people, to give me their preferred option here, right? Either you prefer A, you prefer B, or you prefer C, which is nothing. And I ask you actually 7 times, because I present you 7 of these different choice cards to each of you. So I have 7 of answers of each of you times 1,000, because I have 1,000 of you. And I am going to run a regression. Whatever regression you are we are going to be discussing, but whatever regression I run, there is no need to control for endogeneity. So my question is, why will I not be controlling for endogeneity? And that goes to the core of what econometrics is. One question that you could ask yourself, and sometimes some very conventional econometricians have asked me. They say, where is the econometrics here? This is statistics. Is this econometrics? They ask me. And I very happily say, yes, it is econometrics. Because I am controlling for endogeneity. Just not through the regression or at the regression stage. I control in advance. How? Well, it's very easy. I asked you to choose your preferred option, but you are not choosing together the outcome and the price. The prices that I present to you are exogenous to you. So you have to choose a bundle of alternatives. One of them is the price. But when you come to choose between these alternatives, it's not like, oh, well, I want this pizza at 10. It's if you want that pizza, the price is this. Or you want this pizza and the price is this. Which one do you want? Right? If you were able to say, I want a pizza with this, and I want to pay 10 pesos for it, $10, that is endogeneity. Endogeneity is when you are choosing your level of consumption at the same time that you are choosing your price. So we cannot say that there is a causal effect in that context because you are choosing both. In this case, we don't need to control because you are not choosing but what you are consuming at the given price. Of course, you choose the bundle, but you don't choose the price at which you are choosing the bundle. By you choosing different times in these choice sets, because I present 7 to you, I am able to know how much the price matters to you, relatively speaking, to the other attributes. And I'm going to answer actually the question that Sangeeta asked me because it reminded me. In this case, by you choosing different times in these choice sets, I am able to learn what are your preferences with respect to the parking spaces relative to your preferences for percentage of facade. So to answer your question, the way we are measuring in this case your willingness to pay is by estimating the rate of substitution, the marginal rate of substitution between parking spaces and percentage of green spaces. So there I am able to say for each 1% of urban green space increase in urban green space, this person is willing to give up a half of a parking space. That's marginal effect, marginal rate of substitution. And that is what I'm going to be talking to you later on. The beauty of these discrete choice experiments is, and when I started falling in love with the tool is, to me, to tell you the truth, is the simplest, easiest way to explain what a marginal rate of substitution is. Think about it. If I ask you to choose these between these options, and then again present you other choices set with these same characteristics, but other options, other goods, and so on and so on and so on. The econometric technique, what it does is infers how much green you want to have in exchange of giving up parking spaces. That is a marginal rate of substitution. You don't like that one? How much green do you want to have in exchange of 1% of your facade? Marginal rate of substitution. How much green do you want to have in exchange for giving up the lane? That is not marginal rate of substitution. That is rate of substitution, discrete choice, right? Discrete change in substitution. Those are marginal rate of substitution. I am sure that those of you who have studied economics have seen marginal rate of substitution to the end. I have to be very, very truthful. I didn't really grasp it until I started thinking in terms of discrete choice experiments. So another way to think on a discrete choice experiment is that it's a good tool to estimate marginal rates of substitution. Why do I describe it in that way? Because maybe that's the way that it clicks in you. Right? In the previous time I described it as that is a good way to simulate markets when there is no markets, or when there is a market that requires some expansion in the prices. Well, another way to think about it is a beautiful tool to estimate marginal rates of substitution. If you think in that way, maybe in your context, you are thinking very economically speaking, in marginal rates of substitution. Then you need to put two attributes that people have to trade, and then by put them to trade those attributes, you are going to be measuring marginal rates of substitution. So in this specific case, our willingness to pay is what it is. The willingness to pay, when we express it in dollars, is a marginal rate of substitution between dollars and your good. In this case, it's marginal rate of substitution between parking spots and urban green. Whether it's money or it's not money, we can still make it money. But for the purpose of the paper, we keep it in marginal rate of substitution.
So this has more applications, right? So it can go beyond economics.
It can go way beyond economics. That's why I'm using this one, because those of you who might not be economists, or those of you who are economists that are going to have interdisciplinary conversations, or just so that someday you try to think in trade-offs beyond the monetary attribute, that's an example. Not that it's easy, because I haven't found another one actually. One of the contributions that we are going to claim is that this is the first discrete choice experiment that doesn't use money, but it still presents good trade-offs. Because I have seen some discrete choice experiments without money, that my criticism is that they put them to choose between goods. You know what I mean? Like they say they choose between having green and having beautiful parking spaces, and what do you prefer, A or B? Well, if all of them are goods that I prefer, that's not real trade-offs. Okay, so that's why you don't have to be worried about endogeneity, because a discrete choice experiment doesn't let people choose endogenously. And that is another advantage of stated preferences, discrete choice experiments, over revealed preferences, whether the conventional econometricians like it or not. Now, just to give you more ideas of where you could take your research and your applications, think about it. If you have a data set that doesn't have endogeneity, and you have another data set that does have endogeneity, and they are modeling similar situations, you can combine them to control for endogeneity in the revealed preference. One of the papers I have been working for 5 years is trying to do that. It's modeling, is showing how we can do that. Control for endogeneity with discrete choice experiments. Because you don't have endogeneity in the stated preferences, and if you can replicate or more or less correlate the two situations, then you have an instrumental variable. As easy as that. So that is one thing that you should write down there. And I am not dealing with that here, but I have the working paper out there already online. In case that one of you approach me and I can share it with you, or I can direct you to it. I just didn't want to bring it here because it's not, for a 5-year course, it's not the main point, but I just want to throw the idea for those of you who are into playing with econometrics. Okay, and the other thing is collinearity. And that is where I'm going to spend a little bit more of time, because it has to do with your question of how do I design this? And then it has to do with the fact that then we don't have collinearity. Okay? So let's talk about the market of cars and the market of the real estate market, the houses. Those markets have crazy collinearity. Why? Because usually you don't have a sport car with a super powerful engine that at the same time is energy efficient or compact, right? It just doesn't go together. So on the other hand, you have compact cars that tend to be more energy efficient and tend to be slower. So you really cannot observe how much people will be willing to pay for a super fast compact car or for a super efficient race car. The same with houses, right? Houses tend to be either big and with pool and with all these amenities, or tend to be small and with none of those amenities. The segmentation is that clear. So there is not these combinations between, oh, I want a small house but with a pool. That just doesn't exist, right? There is not out there in the market. So when you describe as a bundle the good call house or the good call car, in the real markets, there is a crazy collinearity. There is not enough variation to separate preferences for square meters and rooms, right? Ideally, when you run those type of regressions, and raise your hand if you are not following me, please. I am just assuming an initial level of regression understanding, okay? But if you don't follow me, raise your hand and I can go. Yeah.
This part, I think you can explain, elaborate a little.
Okay. So when you run a regression, ideally what you want to do, ideally, is to know how much people are willing to pay for extra square meter, but at the same time, for an extra room, no? I mean, you could have a big house with 2 rooms, or you could have that same house with 3 rooms. And some people will want to pay for the extra square, but some people will want to pay for the extra room, and some people want to pay for both. Now, the fact that in the market they kind of come bundled together, there is not too much more square with few, with more rooms or with less rooms. The fact that they come together means that when you run the regression, the collinearity doesn't allow you to impute values separately to square rooms, to square meters and rooms. Ideally, you wish you could. The other example is greenness or closeness to greenness. I am assuming that the market here in Delhi is very similar to the market in Mexico City. If you are close to Chapultepec, which is this beautiful big urban park in Mexico, the price goes to the roof. But at the same time, these are very luxurious or more luxurious houses. You are not going to find that luxurious house in Netzahualcoyotl, which is very much in the north, in a neighborhood where it just doesn't make sense that they will be building those apartments. So when you run the regression, you don't know whether the regression cannot tell you whether the apartment is very expensive because it's in front of the green, beautiful space, or because in itself is very luxurious. And of course, it's because of both. But the collinearity doesn't allow you to separate the coefficients. You put one or the other generally, right? But ideally, you wish you could, because those coefficients will reflect how much of the price of the apartment or the rent of the apartment is due to be close to green spaces or is due to the luxurious component.
If I just may add, we'll be more able to relate if we say that a colony where air pollution is low.
There.
Right? So those houses in South Delhi, they're more expensive. Is it because it's a luxurious colony or is it because air pollution is low? So that kind of separation our experiments would allow. Real data may not allow.
Exactly. Exactly. They come together. They are in a place where there is cleaner air and they are luxurious. You wish to see a luxurious one in a place where there was less clean air. And then you could run the regression and see how much it was because of the clean air. The other example that is very typical is education and income. Right? Do you have a better salary because your parents had education or because they had income? You don't know, because they come together usually. They are very collinear. And usually in those regressions that are called Mincer equations, for those of you who are experts on the labor economics, I think, you have to keep one or the other. Or do someone mentioned component analysis. You build an index of a principal component analysis to build an index of wealth of your family to begin with, right? That bundles income and education of your parents. So that's what we usually do with revealed preferences when it comes to collinearity. But in discrete choice experiments, we don't have collinearity. Why? Ideally, for the time being, we haven't discussed details, but for the time being, imagine that I already came out with my choice, with my design. We have 3 attributes. The distance to your house, which is going to take value 15, 30, and 1 hour, 15 minutes, 30 minutes, or 60 minutes. And then whether the office where you're going to be working has or has not safe biking spaces. And then the monthly discount, which is going to be 35, 100, 150, and 350. Something like that. And I'm going to start answering your question. I define already 3 attributes and their levels. Ideally, think about it. In the ideal world, you want to combine every level of every attribute with the other attributes levels. Do you see what I mean? You combine all of them to create as many goods as artificially or hypothetically you could create by combining the attributes. Is everyone following me? Yes? I'm going to give a specific example, but well, let's do one. If you have 2 attributes and each attribute has 2 levels, you will be creating 2 times 2 for goods, hypothetical goods, right? So, and then you will present it to the person, the 4 of them, plus the alternative of choosing nothing, so 5 in total. And you will be asking to the person, please choose your preferred option from these 4 alternatives plus the status quo or the nothing option. Now you could start realizing how if I increase attributes or I increase levels, I am going to end up with 150 potential hypothetical goods plus the status quo. And maybe at this stage you can realize that that combination takes collinearity to 0, no? Because I am breaking collinearity by combining every single attribute and level with the other one. So collinearity is not an issue there. Now, what is the issue? Who of us can choose among 151 goods? Okay, here is 150 goods. Tell me which one is the one that you prefer. None of us can do that. That's why we came out with the concept of choice sets. A choice set, you have as many choices as you decide alternatives to put in a choice set of those 150. So for instance, if I have 150 potential hypothetical goods that have 0 collinearity, and I decide to put them in groups of 3, then I have 150 divided by 3, 50 choice cards, right? And then I present to you only 50 choice cards. I'm still in problem, no? Who of you wants to answer 50 times, right? Now choose this. Now see this and choose. Now choose the, after the 3rd, 4th, you are like, okay, what are we doing here? You just don't have the cognitive, none of us have the cognitive skills, not the skills, patience. It's more patience than anything else. Okay? So that is called choice sets. Then we create blocks. We say, okay, I'm not going to be crazy to present everyone with 50 choice sets. I'm going to create 5 blocks of 10 choice sets each. Do you see what I'm doing? I'm dividing the sets. Now, instead of having 50 that I want to present to each of you, I have 5. Each of them have 10 choice sets. And now, more or less, I could go and to each of you present 10, and then 10 different ones, block 2, block 3, block 5, until block 10. Does that make sense to you? Right? I could do the opposite. I could have in the previous one I had 10 choice sets in each block, so I had 5 blocks. But I could have 5 choice sets in each block and have 10 blocks. Right? And then I present to each of you one of those blocks. And then I analyze the data, assuming that whatever answer that you presented, your neighbor is going to be answering more or less as if it was you, blah, 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 blah. That's the assumption behind. And it's called homogeneity preferences. And when we use conditional logic analysis, we assume homogeneity preferences. We are going to use mixed logic in some point, and then we are going to break apart that assumption. But to begin with, let's assume homogeneity preferences. Now we have then, that's basically what we do to answer your question. Once you have the attributes, the levels, you combine them all. You realize I have way too many potential goods, so I'm going to put them in choice sets. And then you say I have way too many choice sets, so I want to put them in blocks. And then I'm going to allocate randomly the blocks to my respondents. And they only see a subset of your 150 goods.
Is there any pattern in putting these in the sets or blocks that we're talking about?
As long as it is random, it's okay. Because the randomness implies that in one choice set, you don't put more or less than one of the attributes levels. So in average, they should be represented around the same kind of, the average trade-off. Okay. It will be bad if at some point I put you to choose only between the very good goods to you and then the very bad goods to you. But by doing it randomly, in average, I am presenting you to the same trade-offs, which is the important thing. Not that I am presenting you to the same alternatives in particular, but that those alternatives reflect in average the same trade-offs. Now, that is called full fractional design. Combining all against all is called full fractional design. Any of you have studied field experiments or experiments like, you know, I learned that when I once took a class of agronomy, and we were designing experiments in the field, and then basically you want to know how many treatments you have, and then with that you basically combine the treatments and you define how many parcels do you need to have. That is what we are doing here, full factorial design. That is what it is. The combination. And then after that, the generation of the choice sets, it's out of necessity because there is no human being that can handle 150 goods. And then the generation of blocks is the same, out of necessity. There is another type of design that is called fractional design, fractional factorial design. And what it means is the following. You kind of can let go a little bit of the perfect orthogonality The opposite of collinearity is orthogonality. That full combination means that the attributes, the variables are orthogonal among each other. The reason why I started explaining this with the reveal preferences and how reveal preferences are collineal, it's because going to this extreme is not that productive, because you end up generating way too many alternatives that in many cases don't make sense. So the first step, once you generate your full factorial, is to go through your 100 alternatives and, once you generate your full factorial and put the choice sets, you check whether there are some alternatives that are fully dominated or that are dominating, which basically means if I come and offer you the most innovative alternative to raise, to do rice cropping at no cost, you are going to choose it. I mean, I'm giving you something in exchange of no price. So that should not be part of your design. And if there is one alternative that is just the worst alternative, I'm charging you the highest price, that can come out in the design, right? Because it depends on your levels and your attributes, and it is your responsibility to get them out of the design. So when you get them out of the design, what happens is that you are reducing the orthogonality of your design, or alternatively speaking, you are increasing the collinearity of your design, right? So when we start talking about that, your design is including a little bit of collinearity. So in the end, what you want to do is you want to have a fractional design that has lost perfect orthogonality, but doesn't have come out to a level where you should start getting worried about multicollinearity. Does that make sense? Are you following me? Because what happens when you are in this side is that you keep looking at the people who seems to be understanding you, and you don't realize that maybe someone is not understanding you. So please raise your hands. We have still 4 days ahead, so we can ask tons of questions. When we are on Thursday and we are on the clock, no more questions. No, not true. Well, anyway, so to summarize, discrete choice experiments should not be something that worries you, where you be worried about endogeneity. And that comes from the fact that people are not choosing their prices, and should not worry you about collinearity. But if you do it in practice, you are going to always have to bear a little bit of collinearity. But still, I go back to the initial point. The reason why I emphasize on the example of how reveal preference doesn't allow you to separate the coefficients is that the beauty of these studies is that you can find how much weight people put to each of the attributes that you are considering, something that you could not do in reveal preferences. You could not separate preferences for efficiency and engine size, because usually the engine size, the bigger, the less efficient, very collinear. Here, you are able to present, as we did in our experiment, high engine size and good efficiency, which in practice usually doesn't happen. So that is the part of econometrics. And the good news is this is an econometric method. And I'm telling you this because I have faced those questions 2 times from very conventional econometricians. I didn't see the econometrics, one said. You are not controlling for endogeneity. How come is this econometrics? And my answer was, well, because I designed it from the beginning to not be worried about collinearity or endogeneity. That's how it is econometrics. It is not statistics, because if it was statistics, it will be associations. But the associations come exactly from not being able to separate effects. No? That's why it's called a partial correlation. Okay. I wonder whether it's time to start letting you ask questions, and I am thinking on those in the audience. Yes, why not? I first start asking for questions in the audience that is online.
Yeah.
so that we let them participate.
So, Sana, do you have those questions?
No, ma'am, right now.
Okay.
Have you asked them? Yeah. You have?
Tell them that this is now or never. Yeah. We can take one. There is one? Okay, good. You can read it, and then I can answer from there so that we don't.
I can
Yeah.
switch on the audio. Yeah.
Shireen is there. Hello, Shireen. Welcome.
We can take one find how much weight people put
Ma'am, could you please
to
repeat?
each of the attributes that you are considering. Something that you could not do in reveal preference.
Hello, am I
You
audible?
could not separate preferences.
Yeah,
Wait,
wait. Yeah, there is two. Yeah.
During the discussion we saw, I mean, can we say that shortcomings of this system could be that, for example, we can use the HP method. We do require that there should be a sufficient amount of awareness or education is required. For example, if people they are assigning the values, so they can do this only when they are having sufficient enough knowledge about the environment, the significance of the environment would have. In the absence of that, definitely we need to have, there should be some sort of educational indicators. I think it should also be attached. Do you think so?
Yes.
That education do plays an important role in assigning the values. I mean, educational awareness, environmental awareness is also important in that case. So can we say that this is one of the shortcomings because for a developing and less developed countries like India, because in developed things are different.
Thank you for the question. For those of you who may have not heard, the question was whether the initial understanding or awareness of people about the specific topic matters and whether that is a shortcoming. And I will say that there are two ways to handle that. One, of course, and this is a great question because so far I have been focusing on the discrete choice experiment in itself. But remember, this is a survey that includes a battery of questions at the beginning before you present the discrete choice experiment, and a battery of questions after the discrete choice experiment. The questions before the discrete choice experiment are going to gather, among other things, the level of knowledge of the topic that people have. Because we cannot assume that people understand or have heard or are completely aware about the topic that we are presenting. So that after that, we can explore how much of the preferences that they're stating vary with the level of initial knowledge of the topic. So you can control for that. It's a shortcoming in the respect that we cannot assume that people know, but thankfully we can control and we can elaborate and we can analyze differences in preferences based on how much people knew or not at the beginning, prior the discrete choice experiment, right? Because if you ask those questions after that, then they already know, or you already introduced them, because part of the question was, should we include an education component or an information component if they don't know? And then my answer is a split sample. If you, with your semi-structured interviews, already know that people don't really know that much about the topic, you should probably make this an hypothesis. Will people change preferences if before presented to the discrete choice experiment, I present them to an information or educational component, right? So you start by saying, well, CO2 emissions, and then blah, 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 like a good paragraph of that. And then after that, you present the discrete choice experiment. Half of the sample. But the other half, you don't present them to that educational component, so that you can test whether that educational component matters.
Okay. So, any other questions?
Okay, thank you so much, sir.
Thank you. More questions?
No.
Okay. That reminded me something. Give me a second.
You get good workout.
Yeah, I get my workout in the courses, right? While I was answering that, I was thinking on saying something. Yeah, I'm going to try to remember, but yeah, that was a very important question that gave me the excuse to tell you. Right now, we are talking about the discrete choice component but a survey of discrete choice experiments includes a pre and post discrete choice experiment. In the pre, you do want to gather information about how much people know about the topic. And in the post, you want to gather how much people understood your discrete choice experiment. You are going to be including questions about whether people remember the attributes, the levels, whether they thought that they were important, or whether they thought that some of them were unimportant, and whether they thought that what they are answering has some policy implications or not. Remember, we are going to be talking about incentive compatibility and policy consequentiality in the next session. One more question? Yes.
Sir, my question is, you talked about full factorial design in this. So actually, any type of design what we're as if now working on, we work on agriculture fields or like in a controlled environment. So I want to know how you're applying this thing on social science field, as if now how you're integrating it into our field and how you're controlling the environment actually. Because like if you go to a place where you want to do any type of design, so you should have some benchmark for it.
That's a very good question. And that is one of those limitations. With the split sample, you want to believe that you have some level of comparison. But yeah, you don't have a before and after. In that respect, is that sometimes when we talk about discrete choice experiments, it's a little bit confusing, right? Because that kind of brings the impact evaluation kind of framework. Before you have a baseline for treated control, and after you have the what happened, and then you can do diff in diff. Here with the split sample, we can do a comparison in only one diff. So not that you could not have a baseline, implement a discrete choice experiment, come back 6 months later, and re-implement the discrete choice experiment. But we don't do it in general because of the budgetary restrictions. Usually the big advantage of a discrete choice experiment is that at once it gathers preferences, and if you are willing to explore a split sample approach, right there you are able to explore. But that's a limitation. We cannot, and in general we don't talk about a baseline. Now, in the split sample approach, and that is something that Charu will be bragging about later on Friday, the important thing is to have balanced samples. Because in that respect, you can argue that in average, the people that receive an information treatment are identical to the people that did not receive this information treatment. That is what gives validity to the results if there are some results to a split sample. And I want to say that Charu will present you. It was beautiful. The average of the two samples that we had here in Delhi were, in average, identical. And that's the most we can do in the context of discrete choice experiment when we do split samples, that they look identical in the means. And then you can attach some kind of a effect to it, but it is not in the context of experiments baseline and everything. Yeah. More questions? Did I answer your question about the design? Yes? Did you get tired? Okay. Now I'm on.
Maybe
Yeah.
So, we know that the full factorial design gives us too many alternatives. How do we reduce those number of alternatives? And maybe you want to talk about it tomorrow, I don't know. But what would be an objective way to, we have this D factorial design, the efficiency.
Oh, thank you.
Optimality.
Something that I didn't talk, thank you. Actually, I was telling you how you end up with a fractional design in general. But in order to have that balance of how much of multicollinearity you want to give up, there is something called D-efficiency or measures of efficiency in general. And basically what they measure is they provide you with a guidance on how much standard errors are you losing of your estimates. That's the basic idea with efficiency. When you have collinearity, the reason why, or the way that statistically it reflects into not being able to separate the effects is in the standard errors. You are able to estimate, usually you are able to estimate point estimates of the coefficients, right? When you run a regression with collinearity, you get the coefficients. The problem is the standard errors. They tend to be so large that you don't have statistical significance. So the D-efficiency and other efficiency measures to ponder how much collinearity you are willing to bear in your design gives you, or basically considers how much will the standard errors increase in your point estimates. And then it tells you, well, at this point you have way too much collinearity, you have the risk of not being able to separate the effects of your attributes. So you are going to, I'm going to be elaborating, but I'm glad that you brought up the concept so that you have an idea, and I relate it verbally to the concept of orthogonality. So something I'm going to do right now, because I think it's a good time, is I'm going to ask people to come forward with an example of discrete choice experiment in your context, or not an example per se, but what would you be thinking that will be interesting to explore in your field, in a topic that you are interested. So raise your hands. And
there is one online question.
Oh, there is one more question. So you have 5 minutes to think about your case.
There is one more online question from Subin. He's asking that can discrete choice experiments answer the causal questions?
Yes. So the way you can think on discrete choice experiments is that it is answering a causal question, in the sense that by varying orthogonally the attributes, and by not letting you choosing them by yourself, it's accomplishing what usually we try in a regular cross-section OLS. And the parameters that we obtain, the partial correlation parameters that we obtain, are interpretable as causal effects. Causal, how much your preferences are changing because that attribute is changing. That's what you are documenting there. And in these times, it's kind of difficult for people to believe, in the sense that these days we are so set in the idea of the before and the after to believe causality. But think in this case we are kind of moving. Causality comes from, at least in econometrics, from not letting people choose the component in the left-hand side of the equation, and in the right-hand side of the equation. And that is what discrete choice experiments do. It doesn't let you choose the right-hand side of the equation. So in that respect is that we are documenting causality. But under those assumptions that we are putting itself in the model. Now, one of your examples. More questions?
So let's go to the example.
Who wants to raise your hand? Yeah, who wants to raise your hand? Yes, please.
You can also introduce yourself.
I am working in health economics from IIT Roorkee. So I am working on non-communicable disease among elderly population of India. So my two of the objectives on determinants of multimorbidity among elderly population, and some of on the basis of health behavior. And one of my objectives based on the economic and non-economic cost of non-communicable diseases borne by elderly people in India. Then the economic costs have evaluated, and the non-economic costs like intangible cost I am going to evaluate from these. So the intangible cause that includes anxiety, pain, and stress, insomnia from management of non-communicable disease. When you are going through some NCD or multimorbidity, you have to bear that intangible cost apart from tangible cost like direct cost, indirect cost, which cannot be evaluated or which cannot be marketed or which cannot be estimated. So my area of interest or my attribute that I am going to evaluate, like anxiety, pain from particular NCD like diabetes, or whether you are going to substitute anxiety from pain, or how much compensation you are willing to pay, or how much compensation you are willing to receive for that anxiety, for that sleeplessness at the night due to diabetes, due to hypertension. So my area of interest and my scenario is like that.
I like it. I do like it. There is in health economics one non-market valuation method that we are not covering here is avoided cost. So how much are you spending on pills to sleep today, or a population of people with diabetes, how much do they spend? And then basically one way to interpret is if we were going to tackle that component, they will be saving this much money in pills, so that is an avoided cost. So that is something for you to keep in mind, because in terms of external validity, when you implement a discrete choice experiment, you want to compare it with avoided cost estimates for external validity. The one that I can think right now out of the top of my head, I will do a discrete choice experiment where I ask people, you have the possibility to I am thinking. So you wanna infer how much people will be willing to pay to avoid the anxiety component or the sleepiness component.
Maybe she can also look at marginal rates of substitutions between different, discomfort levels. Is it like, you're willing to bear pain, or you're willing to bear insomnia?
That is a good one, actually.
Yeah, actually, I have been to hospitals and medical centers dealing with people going through diabetes and all. So, the scenario I absorbed from that, like the people are like, we must get the diagnosis of this in our hometown or nearby our house. So, we don't have to travel. We are ready to bear that. That pain we are ready,
Yeah.
that we are ready to get that, but we get money for it to for in compensation. Actually, it is based on the lower middle income countries, like how the income setup of that family, particular family is. If they are left, they don't have a leg or they don't have a arm, so that they are getting reservations or in the jobs like this, so they are getting compensated, they are happy with that. Kids, okay, we have diabetes, if in case we are getting a reservation in jobs, we are happy living with diabetes. Yes.
Very interesting research you're doing.
Yeah, but then that is already revealed preference, because but what you want to do is you want to see if they are willing to, whether will they be willing to give up if they were able to remain with diabetes but being able to sleep and being able to not have anxiety. That will be the value. We have to think on something that the scenario, because basically what you are revealing is that they are willing already to live with diabetes, but also you know that if possible they would like to live with, to have better sleep and to have less anxiety.
Sometimes low income families, the main problem is they get intangible costs from bearing tangible costs. Like they have too much to pay for the surgery or the drugs or the medicines, so they are getting anxiety for this. They are getting pain for this. So there are too much collinearity I am getting in these kind of aspects. I'm getting intangible consequences consequences of tangible cost. So
Yeah, no, but
things are getting tangled.
what we have to think about is keeping diabetes fixed. What is the value to decrease anxiety and what is the value to decrease sleepiness? That is a good example, a very good one. I will need some time to think about it. It is the very first time I think about this case. I will be doing my homework as well tonight. But this is a very interesting case. Tell me something. Who will be your consumer of your results, of your findings? Is it an authority? Is it a government agency? Like these values, who do you want to communicate them to?
The participants of this experiment would be elderly people living with non-communicable diseases.
Okay.
Having two or more than two multi-morbid patients. So there are major 8 diseases I'm working on, including diabetes, hypertension, arthritis, respiratory and cardiovascular diseases. So we are focusing on those people.
Okay.
So we are targeting hospitals and NGOs and elderly care centers.
So your findings will be useful for hospitals, for instance?
You can.
Okay, okay. I am trying to think that also to see how we could set up, for instance, in this case, slowly but surely I am thinking on a scenario where you present some sort of treatment when people come to the hospital. And in that treatment, you basically vary sleepiness, anxiety, but in terms of diabetes, you more or less keep it as it is. But what you want to control is for the sleepiness and the anxiety. I'm going to be thinking on that. So right now, for tomorrow, for the next conversation with you, I think that a productive, constructive conversation is around, because you are the one who has better context, think on a situation in which you can present to the patients a situation in which they arrive to the hospital and they are able to receive certain treatments where you vary attributes and you vary the level of decreasing anxiety and decreasing sleepiness. And I think that you basically keep the diabetes fixed.
Yeah, keeping that. Yeah, in case of arthritis, we can fix pain.
Exactly.
Exactly. So it will vary from disease to disease or from cases to cases. But at least for a single case, I want to get a scenario, broad scenario, what I'm going to do.
Exactly. Okay, we are going to keep talking about it. Okay, that was a very good example. Okay, we need to wrap up. Thank you.
3.5 hours and
And I want to keep talking. Thank you so much.
Make one announcement.
So as part of evaluation, because this program also we want to evaluate your learning, I suggest that I encourage you guys to think about some example, like she had one in a group of 6, and one of you can have an idea and others can just join in and try working on these, so that by the end of it, by Friday, we'll give you some time and you can present your ideas to us. So I think that'll be an outcome that we're looking for this course. Adam, you want to?
I can complement that. Actually, these days I will ideally like you to come up with even the illustrations of your potential discrete choice experiment, because with ChatGPT, I have some students have been able to come up with a general kind of description of the illustrations. You don't have to work too much. When we at the beginning did it, we didn't have ChatGPT, and so the illustrations came until later when you were more sure. But I think that right now, kind of interactively working, and if you are going to be 6, some of you can be thinking on how the illustrations will look, and that helps a lot to communicate in a discrete choice experiment. Actually, that reminds me, something I'm going to be talking about is virtual reality. The next step for discrete choice experiments is virtual reality, because it's the one that gets you the closest.
Virtual reality.
So we will be talking a little bit about that. Thank you, everyone.
So we wind up for today, and we'll see you tomorrow at 2 p.m. same venue.